This is our max class. In the previous class, we have seen some examples of exercise 2.6. Today, in this video, we are going to learn how to do the solution of remaining examples in exercise 2.6. First, let us recall some important points of an arithmetic progression. In an AP, the general form is A plus D, A plus 2D and so on. Next we see the nth term of an AP is Tn is equal to A plus n minus 1 into D. Here A is first term, D is common difference and n is a nth term. The next point, number of terms of an AP is equal to L minus A divided by D plus 1. Here L is a last term, A is a first term, D is a common difference. The three consecutive terms of an AP is A minus D, A plus D. Here the common difference is D. Then the first four consecutive terms of an AP is A minus 3D, A minus D, A plus D and A plus 3D. Here the common difference is 2D. Next we see some important points of an arithmetic series. The general form of the arithmetic series is A plus D plus A plus 2D up to nth term A plus n minus 1 into D. Sum to n terms of an AP, that is Sn is equal to n by 2 into 2A plus n minus 1 into D. Then another formula, Sn is equal to n by 2 into A plus L. In the question, when first term and common difference given means use this formula and find the sum of n terms, or in the question first term and last term are given means using this formula find the sum of n terms. These are the important points to remember of this exercise. Let us see the example 2.34. See the question. The 13th term of an AP is 3 and the sum of first 13 term is 234. Find the common difference and the sum of first 21 terms. In this question, the value of T13 is 3 and the value of S13 is 234 are given. We have to find the common difference D and find the sum of the first 21 terms, that is find the value of S21. Let us do the solution. In an AP, T13 is equal to 3 and S in an AP, first you take down and write the given T13 is equal to 3 and S13 is equal to 234. Now you have to write the general form of T T13, that is A plus 12D is equal to 3. This one we take first equation. Then next you have to write the formula for Sn, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Here n is 13, so 13 by 2 into 2a plus 13 minus 1, 12 into d is equal to 234. Here 2 is a common factor, so you take out 2 means we get, see the next step, 13 by 2 into 2 is a common factor, so you take out 2 means 2 into a plus 6d is equal to 234. Now you have to cancel this 2 means, now we have 13 into a plus 6d is equal to 234. It can be written as a plus 6d is equal to 234 by 13. Now you have to cancelling this by 13 table, that is 1 13s are 13, 18 13s are 234. Now we have the equation a plus 6d is equal to 18. So let us assume this second equation. Now you have to take down and write the first equation, that is a plus 12d is equal to 3, and second equation a plus 6d is equal to 80. By using elimination method, we have to find the value of a and d. Let us see. Now you have to subtract this 2 equation, means change the sign, minus, minus and minus. Therefore, plus a and minus a cancel and get 0. Then 12d minus 6d, we have 6d is equal to 18 minus 3 minus 15. Therefore, the value of d is equal to minus 15 by 6. Now, you have to cancel this by 3 table. That is 2 3s are 6, 5 3s are 15. Therefore, the value of d is equal to minus 5 by 2. Have to substitute this value in the first equation and find a. See, substitute d is equal to minus 5 by 2 in first equation. First you take down and write the first equation, a plus 12d is equal to 3. Here a plus d, here a plus 12, here d is minus 5 by 2 is equal to 3. Now you have to cancel this by 2 table. 1 2 is 2, 6 2s are 12. That is a 6 into minus 5 minus 30 is equal to 3. Therefore, the value of a is equal to 3 plus 30. That is a is equal to 33. Now we have the value a 33 and d minus 5 by 2. Let us find the value of S21, that is sum of first 21 terms. For this, which formula you have to apply? Yes, Sn is equal to n by 2 into 2a plus n minus 1 into d. Here n is 21. So, S21 is equal to 21 by 2 into 2. Here a is 3. So, 2 into 33 plus n minus 121 minus 120 into d is minus 5 by 2. Next you have to simplify this, means we get S21 is equal to 21 by 2 into 66 plus cancel this by 2 table, 1 2 is 2, 10 2s are 20. Now you have to multiply 10 into minus 15, that is minus 50. S21 is equal to 21 by 2. Here 66 minus 50, we get 16. Now you have to cancel this by 2 table, 1 2 is 2, 8 2s are 16. Therefore, S21 is equal to 21 into 8, 168. Hence, the value of S21 is 168 and the common difference D is equal to minus 5 by 2. This is the answer for this question. Now we move on to the next example 2.35. See the question. In an AP, the sum of first n terms is 5n squared by 2 plus 3n by 2. Find the 17th term. In this question, sum of first n term is given. We have to find 17th term, that is T17. For this, first you have to find T1, T2, then you have to find the common difference and apply the nth term formula. Let us do the solution. First you take down and write the given. In an AP, Sn is equal to 5n squared by 2 plus 3n by 2. First you have to find the value of S1, that is replace n with 1. Therefore 5 into 1 squared by 2 plus 3 into 1 by 2. Now you have to simplify this, means we get 5 plus 3 by 2 because here 2 is a common factor. Therefore we have 8 by 2. Now you have to cancel this, means we get 1 2 is 2, 4 2s are 8. Therefore the value of S1 is equal to 4, which is implies T1. Because sum of first term and first term of the AP are also 4. So, T1 is equal to 4. Then next we have to find sum of two terms, that is S2, which is equal to, you have to replace n with 2. Is 5 into 2 the whole square by 2 plus 3 into 2 by 2. Now you have to simplify this, means we get 20 by 2 plus 6 by 2, which is equal to 26 by 2. Cancelling this, means we get 1 2 is 2. Then 13 2s are 26. Therefore, the value of S2 is equal to 30. So, this is the answer for sum of two terms So it can be written as term 1 plus term 2 is equal to 30. In the previous step, we have the value of T1, that is 4 plus T2 is equal to 13. Therefore, T2 is equal to 13 minus 4, we get T2 is equal to 9. Now we have the value of T1 is equal to 4 and T2 is equal to 9, that is first term 4, second term 9. From this you have to write the first term A is equal to 4 and common difference D is equal to 9 minus 4, that is T2 minus T1, we get D is equal to 5. In this question, we have to find the value of 17th term. Therefore, T17 is equal to, write the general form of T17. The general form of T17 is A plus 16D. Now you have to apply this value in this form, means we get 4 plus 16 into 5. It can be written as 4 plus 16 into 5. 6 5s are 30, remainder 3. 1 5 is 5 plus 3, 8. So 16 into 5 we get 80, which is equal to 84. Therefore, the value of T17 is equal to 84. This is the answer for this question. Now we move on to the next example 2.36. See the question. Find the sum of all natural numbers between 300 and 600 which are divisible by 7. In this question, you have to find the sum of all natural number between this number which are divisible by 7. Let us do the solution. First you take down and write the given. The natural numbers between 300 and 600. Yes. First you have to write all the natural number between 300 and 600. Between means you don't include the number 300 and 600. Just you should write 301 up to 599. See 301, 302, 303 up to 599. From this sequence, we have to find which are divisible by 7. So, the sum of all natural number between the sum of all natural numbers between 300 and 600 which are divisible by 7. That is, first you have to find the first number which are divisible by 7. For this, I explain one method. See, first number of this sequence is 301. Let us divide this 301 by 7. Therefore, we get 4 sevens are 28, remainder 21, remainder 2. Then you take down this 1 means we get 21. Then 3 sevens are 21. Therefore, remainder 0. Therefore, 301 is exactly divisible by 7. First number you have to write 301 plus adding 301 plus 7 we get second number, that is 308, plus the next number 308 plus 7 we get 315 plus going on up to, for finding last number you have to divide the last number 599 by 7. That is 8 sevens are 56, then 9 minus 6 we get 39. That is 59 minus 56 we get 3. Then next you take down the next number, that is 39. 5 sevens are 35, remainder 4. So here we get the remainder 4. So you have to subtract this remainder from the dividend, that is 599 minus 4 we get 595. Therefore, the last number which is divisible by 7 is 595. Therefore, the terms of the above series are in AP. Here A is equal to 301 and common difference D is equal to 7 and last number L is equal to 595. So here we have to find sum. So we need n. For finding n, you have to apply which formula? Yes, n is equal to L minus A divided by D plus 1. Now you have to apply this value in this formula, means we get n is equal to last term 595 minus first term 301 by common difference 7 plus 1. To simplify, 595 minus 301 means we get 294 divided by 7. Now cancelling this by 7 table, 1 7 is 7, 4 7s are 28, remainder 1, 2 7s are 14. Therefore, the value of n is 42 plus 1, we have 43. To take down and write the value of n is equal to 43 and A is equal to 301, then L is equal to 595. Now you have to find the value of S43. Formula n by 2. Here n is 43. So 43 by 2 into 2a, 2 into 301 plus n minus 1, 43 minus 1, 42 into D, common difference 7 Therefore 42 into 7. Now you have to simplify this, means we get S43 is equal to 43 by 2 into 2 into 301, 602 plus 42 into 7, we have 14, remainder 1, 28 plus 1, 29, that is 294. It can be written as 43 by 2. Now you have to add this two number, means we get 6 plus 2, 8, that is 896. Now cancelling this by 2 table, 1 2 is 2, 4 2s are 8, 4 2s are 8, 8 2s are 16. So we have 43 into 448. Now you have to multiply 43 into 448, means we get S43 is equal to 19,264. 19,264. This is the answer for this question. Sum of. Let us see the next example 2.37. See the question. A mosaic is designed in the shape of an equilateral triangle. 12 feet on each side. Each tile in the mosaic is in the shape of an equilateral triangle of 12-inch side. The tiles are alternate in color as shown in the figure. Find the number of tiles of each color and total number of tiles in the mosaic. See the given figure. This is a mosaic is designed in the shape of equilateral triangle of 12 feet on each side, and the tile also is in the shape of an equilateral triangle of 12 inches, that is 1 feet on each side. In this question, first you have to find the number of rows. In this question, first you have to find the number of rows in a triangle mosaic. That is, number of rows is equal to side of a mosaic divided by side of each tiles. That is 12 feet divided by 1 feet is equal to 12 rows. Let us do the solution. In solution, first you take down and write the given side of a mosaic is designed in the shape of equilateral triangle is equal to 12 feet. The next given side of each tile is designed in the shape of equilateral triangle is equal to 12 inches. We know that 1 feet is equal to 12 inches. Side of a tile also 1 feet. You have to find the number of rows in the triangular shape mosaic. That is, number of rows is equal to side of mosaic divided by side of each tile, which is equal to side of mosaic is given in the question, that is 12 feet, divided by side of each tile are also given in the question, that is 12 inches, is equal to 1 feet. Therefore 12 by 1. Now you have to divide this, means we get 12. Therefore number of rows is equal to 12. That is, the value of n is equal to 12. Next we have to find number of white tiles and number of blue tiles. See, first you have to write number of white tiles. From the figure, this is the first row and this is second row, third row, like that going up to 12 rows. Here you have to count the white tiles. See, in the first row there will be only one white tile, and second row 2 white tiles, and third row 3 white tiles, like that going up to 12 rows. In the 12th row there will be 12 white tiles. Therefore, the number of white tiles in each row is form an arithmetic series. So, you have to write number of white tiles in each row of a mosaic is form an AP. That is, number of white tiles, Sn is equal to 1 plus 2 plus 3 up to 12. Here A is equal to 1, L is equal to 12, and N also 12 rows. Now you can use the formula Sn is equal to n by 2 into A plus L, because here we know first term and last term. Now you have to apply this value in this formula, means we get number of white tiles S12 is equal to by 2 into 1 plus 12. Now you have to simplify this, means 1 2 is 2, 6 2s are 12, that is 6 into 1 plus 12, 13, which is equal to 78. Therefore, number of white tiles is equal to 78 tiles. Next we have to find number of blue tiles. Now again you observe the given figure. Here we have to find the number of blue tiles. See, this is the first row. In the first row no blue tiles. So number of blue tiles starts from 0. The second row there will be only one blue tile. Third row 2 blue tiles. Then fourth row 3 blue tiles. Fifth row 4 blue tiles up to 12 rows. In the 12th row there will be 11 blue tiles. So the series is 0 plus 1 plus 2 plus 3 up to 11. So number of blue tiles in each row are also form an AP. So therefore you can write S B, that is number of blue tiles, is equal to 0. First row no blue tiles, so you start from 0 plus second row only one blue tile, in third row two blue tiles, up to 12th row there will be 11 blue tiles. Here A is equal to 0 and L is equal to 11 and N, there are 12 rows, therefore N is equal to 12. Now you have to use the formula Sn is equal to n by 2 into A plus L. Here Sn is 12, so S12 is equal to 12 by 2 into 0 plus 11. Cancelling this by 2 table, 1 2 is 2, 6 2s are 12, that is 6 into 11. Now the number of blue tiles SB is equal to 6 into 11, 66. Hence, you take down and write the answer. Number of blue tiles is equal to 66 tiles. In the question, they ask find the total number of tiles also. Therefore, the total number of tiles is equal to sum of white tiles plus sum of blue tiles, which is equal to 78 plus 66 is equal to 144. Hence, the total number of tiles in the mosaic is equal to 144 tiles. This is the answer for this question.